Hello everyone and welcome back to another GhostEngine devlog series. Today was not a good day for science. Firstly, I've done the work for this user story, basically implementing a resource manager. Then I noticed that I did not record the work. And then I wanted to record a review of the work I've done, and I've noticed that I did not record the review. So this time we are safe. I made sure that I'm recording the review. So for this user story, we want to implement a resource manager that manages resources for the entire lifetime of a GhostEngine application. And we want to be able to do some basic things with it, like adding a resource of any type, integers, structs, floats, so on and so forth. We can remove the resource. The resource of the same time can be distinguished. We actually did not implement something, but we make sure of something that Rust provides for us to be able to differentiate between resources of the same type. And of course we want to get const or mutable reference to our resources to check the values we have in there, or to mutate the values. Now let's go to the code. This is our resource manager. We basically have a hash map, and we keep track of this link between a type ID of the concrete resource, and we store it in a boxed resource trait. Before I go further and explain how I implemented the resource manager, let's go to the tests and review a little bit what scenarios we are covering with our unit test. So we make sure that the resource manager is default constructible. Then we make sure that we can register a resource at the time we are building the resource manager. Then okay, and we have two scenarios: simple resource like view size floats and so on, and object resource like struct. And you see, this is the feature of Rust we are using to differentiate between two floats. We are actually wrapping the simple resource in a unit struct, and that's how we can store two floats in our resource manager. We check that we can add a simple and object resource. Okay. And we check that we cannot add a resource. Why? Think about this scenario. You initialize your application, you register the resources there, and during the update stage you do some computations and store the result in a resource of type speed, for example. And then by mistake, or maybe intentionally, you just do resource manager add resource of type speed. Most likely than not, you don't want to overwrite the results of the computation you did earlier. You want to been notified that the resource is already registered. And when a resource is already registered, you get this error. The add resource method basically returns a result, either an OK or an error, a resource creation error. Next, we check that we can get const references to our resources. Okay, perfect. And now I see something. Instead of going with 0 and so on, we'll just go use size default and speed default. Okay. And that. Okay. I think it's clear this way. So what we are doing in those tests, we create a resource manager with a resource of type speed in this case, and we want to make sure that the resource we get from our resource manager, it's default constructed. Next, can update simple resource. So we basically get a mutable reference to the resource, we mutate it, and then we check that the mutation happened. For this case, when we are working with a wrapper struct, you say we get our x, that's a mutable reference to a speed struct, and we modify the field 0. This is not a named field, but it's the first field, which is the 0 field. Can remove simple resources, so we create our resource manager with a resource, we remove the resource, and we check that we get none when we query for that resource. So those are those scenarios. That's what basically what we have here in the acceptance criteria. Let's go over the implementation. Where are you, my friend? So we start from here. Now, I mentioned that we are storing our resources in something that implements resource trait. What's resource trait? Resource trait is this trait, and for all types of resources we want to have available those functions, so we can cast from the resource trait to the concrete resource type. Next, we have a resource. This is basically just a generic wrapper for a concrete resource type. And here is the nice thing about having this resource wrapper override. You see, we implement the resource trait that's not tightly coupled with any generics, So we implement this trait for all resources of type T where T is default constructible and has a static lifetime. And for all of this, we implement our functions required by resource trait. We can't go with something like this, or we can actually. I just now realize it. Let me check something. Ooh. Okay. Yeah, because this one also covers this when T is this. But yeah, I won't go into details about this, but I'll just come back to this implementation. And I leave it like this. Yes, I leave it like this because I don't want to have my resource trait implemented for simple or other. I don't want resource trait to be implemented for hash map, but I want it to be implemented for resource. If I can type hash map. I'm not sure if the difference is clear for you. If not, let me know in the comments below and I'll try to do a better job at explaining it. Okay, so let's clear that and make sure I did not break anything. Okay, so we have those traits and structs and implementations defined. Now let's go to the actual implementation of our resource manager. For method with resource, we get mutable ownership of ourselves. We insert the resource in our storage, which is a hash map. And as I said, we link the type ID of our resource to a boxed resource. And the value of that boxed resource is the default value for T. When we add the resource, it's similar with the exception that we do the check that the resource is not already registered with our resource manager. If it is not, we add it. When we get a reference to our resource, what we do, I'll explain here for the const reference, but it's basically the same for mutable references. We just have mute in a few places. So we go to our hash storage. That's a hash map with key type, type ID, and object type boxed resource trait. So we look for the value corresponding to the type ID, and this one can be there or cannot be there. If it is there, we get that boxed resource trait from our box using x.asref, and we get this, an optional resource reference to a resource trait. With the resource trait, we use the functions from our resource trait, and we downcast it to resource of type T. And when we have a reference to a resource of type T, we retrieve the concrete, a reference to the concrete resource. Similarly for the mutable case, as I mentioned, we have mutes in all those places. When we remove a resource, we just delete the stuff from the hash map. And that's basically it. At the moment, I'm not sure we are covering all the use cases with the current implementation. Either way, we will update our resource manager in the future if there is a need for it. If you liked this quick and short review of our work, click on the like button, subscribe, and click on the notification bell to be kept up to date with the series. And until next time, bye bye.